Hello, everybody. This is Mr. Ege, and our project today is continuation of the mechanical clock with gears, and this is the second day of the gear assembly. And previously, we did created number of the gears behind the mechanical clock. If you recall, we generated the front plate of the mechanical clock initially as a part drawing, as separate. And then we generated second arm, minute arm, and our arms separate part drawings. So we have 4-part drawings. Then we put them all together in a new assembly drawing. And we placed them one by one. And then after that, we constrained each one of those 3 parts. And after which, we decided to go with the gears behind the clock. So if we turn the clock a little bit, okay, you will see the second arm, okay, is connected to the small gear, which is connected to the large gear, okay? And they are all constrained to each other rotational-wise, motion rotational-wise, okay? And that enabled us to rotate these 2 gears. However, when the second arm gear rotates, larger gear connected to one of the fixed axles, around the fixed axles rotate as well. And that gives me a mechanical advantage of 3, okay? And 3 mechanical advantages, 3 meaning that the small gear rotates once and large gear rotates 3 times more. So you have to count large gear rotates 3 times less, I'm sorry. So you have to count the number of the teeth accordingly. We decided that the relationships earlier between the minute arm, second arm, and between minute arm and our arm. And we decided that the relationship between the minute arm and second arm is going to be 60 MA or 60X. And that means that if you happen to use only 2 gears, that's the mechanical advantage will reflect the ratio, proportions of the number of the teeth between 2 gears. And so 60 was too big, is yielding to one very, very small gear and one large, very huge gear, okay? So we didn't want to go with that. We wanted to divide the 60 into the smaller parts. So 60 actually can be multiple product of 3, 4, 5. 3 times 4 times 5 gives you 60. So we divided that. So we divided, basically break down the entire mechanical advantage of 60 into 3, 4, and 5 mechanical advantages. When you multiply by 3 of them, you get the same number, 60 again. So each mechanical advantage reflects the relationship between 2 gears. So you have to think 2 gears for each mechanical advantage, okay? So the second arm is connected to a small gear with 1, 2, 3, 4, 5, 6, I think it's 6 teeth. So when you rotate that, okay, it generates the larger gear, and then when you rotate and continue rotating, small gear rotates to larger gear rotates to small gear, and small gear rotates to larger gear, and in that order, okay? So basically the motion is going to be slowed down, the purpose of that, okay? And when you see the second arm is sticking out in here, it's connected to smaller gear, and it simply rotates the larger gear over here, which is axle around the axle, okay? And the larger gear, okay, now connected to a smaller gear and constrained to it, okay? That smaller gear, now this time operating much larger gear, which is 4 with that mechanical advantage of 4. So whatever the number for 5 teeth times 4, 20 teeth over there. So any large gear is connected to smaller gear which rotates it, and smaller gear is mashed into the much larger gear. So this is the second arm, the way the second arm operates, okay? As you can see, you rotate the second arm clockwise, everything is rotating properly and slower. However, the largest gear is extremely slow, and also it's rotating in a counterclockwise fashion. This is only normal, okay? And sometimes we have to reverse that counterclockwise fashion but I'm not going to do that until I work with, okay, with the minute arm, okay? So this large gear, okay, we have right now 6 gears connected to it, mashed into each other. We're supposed to directly relate to the minute arm, okay? Minute arm gears are going to be separate, but I have to connect this large gear right now to the minute arm in a fashion to correct the counterclockwise motion. As you can see, everything turns correctly in a clockwise fashion, but the large gear rotates in a counterclockwise fashion. Now, I cannot connect the large gear into the directly to minute arm. So what I have to do, I have to find out two other gears, okay, to rotate the minute arm to reflect the relationship between the large gear and the minute arm, okay? So that counterclockwise motion is corrected. Okay, they need to be in the same size, all right? So I'm going to go with the, again, design, as we did before. So the spur gear, click on the spur gear option and select the spur gear option on the top, okay? And I'm going to bring it in my, right now in here, so that you can see it, okay? And basically, the gear ratio, I want the gear ratio to be 1. Desired gear ratio to be 1. In this case, 1 to 1. Okay? And number of the teeth is not problem, and it's going to be 5 or more. Doesn't matter anymore. We can make it much bigger. We can make it much smaller. Previously, we used 25, 5 to 25. I'm going to just simply select the cylindrical face first, okay, for the first gear, and cylindrical face of the second gear, which is minute arm, and then I need to select the starting plane, okay? To do that, I have to rotate entire system a little bit. See if I can reach. No, I can't. No, I can. Okay. And everything has to be. Now I have to press the calculate button. Calculation is made. Okay. And each one of them has 5 teeth. Okay. Now I'm going to click OK. And I'm going to click OK. And accept. Okay, so now we're going to take a look at the way everything operates, but basically they seem to be working fine. Now I need to use the constraints. Okay, constraints are extremely important because only 2 gears are connected to each other, and they are not constrained to the other gears. So I'm going to use, okay, go back to assembly and select the constraint function. And the constraint function, okay, will enable me to motion constrain gears to gears and gears to axles. So first I'm selecting the gears to gears. So the first solution, forward constraining, Okay, so this, I'm selecting the gear number 1. Now I'm selecting the gear number gear number 2. Okay, and just going to apply and to see the result, what's happening. So when I rotate gear number 2 up, it's opposite is happening. So it did not happen in the first time. So the motion constraint has to be adjusted at this point. And this time, we need to reverse the motion. The ratio is 1. There's nothing wrong with this, and the motion has to be reversed. Now this is counterclockwise, and this also going to be counterclockwise. So apply it, and I just wanted to see how it happens right now. Oh, apparently there are two rotation constraints, and that's giving us hard time. So I'm going to erase the second one and see the first one now working. Very good. So first one is working. Now they're rotating correctly, as you can see. Now, next thing to do is to set the correlation or constraint between the smaller gear and the minute arm. Again, I need a motion constraint. A motion constraint has to be, okay, in the same direction, opposite. Okay, and we're going to select okay, for the clockwise. Okay, and I'm going to test it again. All right, so everything is rotating in the correct direction this time, as you can see, but it's much slower rate. I don't see minute arm is rotating, and that's kind of annoying me. I'm going to try it one more time. Again, in the constraint, the motion constraint. Okay, and apply, and see how it goes. Okay, it's the same direction. Now, so as you can see, as a second arm rotates, faster and faster. Minute arm rotates much slower rate, obviously, but I think the precision is obtained, and at this point, I suggest you to save your work. So we have the connection, gears connection between the second arm and the minute arm right now. So the 60x or mechanical advantage of 60, MA 60 is accomplished. Now we have to focus on minute relationship between the minute arm and the hour arm. That relationship is 12x, or mechanical advantage of 12, MA 12. And in order to obtain this, and within a reasonable size of the, we're going to be using break down 12 into 3 and 4. 3 times 4 is 12, and you're going to have 4 gears, okay? 3 is going to command 2 gears, and 4 is going to command 4 gears, required 4 gears, and we're going to be connecting them. So let's go with the MA3 option first, okay? And I'm going to go back to design mode, select the spur gear and spur gear option. Now here, we're going to change the desired gear ratio to 3, okay? And then press calculate so that everything is decided. So number of teeth of the first gear is going to be 5. Number of the teeth for the second gear is going to be 15. And so that we can select the cylindrical axle, okay? The first cylindrical axle is going to be minute arm. So I click on that, and I'm selecting the minute arm. The second is cylindrical axle face of the second gear is going to be in other I'm selecting a different free axle. I may be wrong. I apologize. Okay, maybe this is not a free axle. I thought it's a free axle, but I have to see actually if it has happened, really free or not. And let me see. Oh, it is free. Okay, good. I thought it's not free axle. And now we're going to select the starting plane. So I click on the arrow next to starting plane, okay? And this time you're going to be selecting the face of the last gear. And click. And computer instantly generated, okay? The 2 gears, you can see that in green line. And you're gonna click OK, okay, and then you're gonna click OK and accept, okay? And now you need to see how it's behaving. So if you move your cursor over the small axle and try to rotate it, seems to be it's working good. Now we need to put the constraints so that 2 small gears are supposed to be constrained, okay, to the axle of the minute arm, okay. First, 2 small gears are supposed to be constrained to each other, okay, first of all. And I'm going to do just that and go to assemble, assembly, and constraint, and select the motion constraint, and select the first motion, and that's going to be, is what we can do, and we can just click the surface, and then we can just literally click the surface of the second gear, okay? And apply, and let's see if they're behaving properly. We're all close now. And okay, they're rotating together. Okay, so they are constrained. These two gears are constrained nicely. And next thing to do is constraining the gear to the axle. So for that, just simply go to constrain, go to motion constrain again, and select the axle. This is counterclockwise constraining. It doesn't matter as long as they're constrained. Click on it, okay? And now the next one's supposed to be constrained. Same fashion, counterclockwise. Apply. Okay, now we need to see whether it's working. I'm rotating the minute arm this time. And it's not rotating. When this happens, okay, there's usually something is wrong. Rotation, so last rotation, axle did not work properly. So what we're going to do, we're going to erase that. It did not work properly, so I'm going to erase this. Okay, hold on a second. Click, click. Either I'm going to replace it. Okay, and maybe we should enter -1 here. See, probably it's not going to work. Is this going to work? Not really. Okay, and we can delete that and do the constraint one more time. Oh, what do you know? Okay, so it is rotating. Now the gear is rotating as the and minute arm is rotating and his gear is rotating. Apparently that worked for us. Okay, cool. And now this is the mechanical advantage of 3 connection. Now mechanical advantage of 4 connection, okay, has to be done. And to do that, okay, we're gonna need to design component. We need to go to spur gear. Spur gear is right in front of us now, and I'm going to modify the desired gear ratio from 3 to 4. Okay, and I'm going to click on the calculate so that computer generates the number of the teeth properly, and 5 teeth. First small gear is going to be 5, and then larger gear is going to be 20 teeth. So the calculation is done. That means I need to select the cylindrical face, okay, and to slow the motion even more. Now, the cylindrical face of we're slowing down the motion. So cylindrical face, okay, will be here. Which will be connected to minute arm, click, and the other cylindrical face, okay, should be connected to I'm sorry, I'm going to have to escape from this one because we already created one of them. So next cylindrical face is going to be large one. I apologize. Let's go to design, go to spur gear. Let's create the spur gear dialog box, and number 3 became number 4. Okay, we calculated, so 4 times 5 is 20. And cylindrical face is going to be the last larger gear. Okay, So we go to last larger gear and select the cylindrical face on that. And then the large second gear cylindrical face is going to be the hour arm. So I'm going to choose the hour arm. Okay. And the plane of the first one is going to be the surface of the hour arm. So we're going to click on the plane, and we need to see the surface. Okay, there it is. Click. Okay. Now, does that work? We're going to try. Okay. The only concern I have is whether it's going to be clockwise motion or counterclockwise motion. And let's click OK this. Okay. And accept. And let's take a look at it. If everything is rotating properly. Okay. So I need to put the constraints as well. Motion constraint. Okay. And apply, close. Now if I change the rotate with arm, gear is rotating as well. Good. There's one more constraint need to be done. Between two gears this time. Again, motion constraint. And this time we'll go counterclockwise and counterclockwise. Okay. And apply. And okay. Close. And I want to see if it is working properly. Okay. So let's rotate everything. Yes, everything is working properly. The emotions are created. Okay, so thank you very much for watching this episode. And now I'm going to, next class, I'm going to focus on number of the other things. For example, I'd like you to create video so that I demonstrate how to generate a video of the rotations. Also, there is a pictorial view, exploded pictorial view that we can create so that we can see and everybody can see. This kind of thing is absolutely necessary for the engineering portfolios, okay, or designer portfolios. So I want to stress on the video creation and video generation of the motions of the clock. And right now we created all the gears, okay, and the arms are perfectly rotating. Arms are all connected to each other, and I'm trying to make it quarter of 9 o'clock. I think that's what it is right now. Okay. And the next class, we're going to focus on a number of other things, including video and exploded view. Thank you very much for your time.